Okay, guys, you see, this is the muscle tissue from the herring. So we need to weigh it somehow, and we need to divide it into, good portions that are usable for us.
Avoiding contamination.
And at the same time, avoiding contamination. Yes.
What weight would you aim for? What weight would you be aiming for?
100 milligrams.
100.
Yeah.
And what we do
in the middle.
Use a scissor or something like that to cut the muscle.
Scalpel.
Scalpel.
Yeah. Let's see how hard it is. That will determine if you need to transfer everything into the mortar and give it a really knock.
You never break the mortar doing that? Because sometimes we break the
I'm not
mortar.
that strong.
You have many mortars. I think it's better to use a scalpel to
Shape it.
yeah.
So what I would do now, normally I prefer a bit larger box than this, because I can have the mortar standing on dry ice.
Okay.
Having the mortar on dry ice instead of regular ice gives you all the time in the world when you are doing the cross-linking, because you can leave the lab and it's still good. So this is already cold, but normally you could just pour liquid nitrogen into it and then it cools down rather fast.
I have a question. How much time the samples can be stored in the dry ice before starting with the effective tissue grinding?
As long as you want. As long as they are frozen, it doesn't really matter.
So it's okay if we take the samples from -80 and put in the dry ice. It can be stored in dry ice
The whole
for I
day,
think
the whole day while you are figuring out
So
stuff.
it's not
And if something happens during the day, you can just return them to -8 and continue tomorrow.
okay. So it's not necessary that.
Okay.
So that's the benefit of dry ice instead of the normal ice. If you kind of start working on that and then it starts to thaw, you have to continue.
Okay.
But normally you know that, okay, I'm doing these samples and you can work on normal ice, but then you have to finish. That's the only difference. All right, so now I would sit down with a weight and pour out if it's not stuck, it's easy. But if it's stuck in the tube, you have to use a spatula or something to try to get it out. I think I have that already.
Okay.
Yeah.
But you don't add, for example, a little bit of water, no? No, you don't want that. You wouldn't add a little bit of water to do the separation.
No.
No.
Because actually you want to keep it frozen.
We need frozen.
Yeah. Any enzymatic activities we want to avoid, right? So
water is
adding
not good.
moisture would start the nuclease breakdown basically. All right, so now I would just go to the weighing room. Normally, if I was doing this, I would have a weight at the lab bench, because running back and forth in a different room, I find it very annoying, and it slows us down, because others are also using that room. So if you're doing this regularly, have a separate weight that you do use for this kind of things. It's just more handy.
And now
Because
we will place also a lid here to avoid contamination or something like that, or not?
Yeah, keep in mind when you start crushing it. So that's the benefit of using regular ice, because you can just pour it out and take new ice. If you have little dry ice and it gets very dirty, especially when you work on plants or something, you see that you have a green kind of shadow around your then it's time to maybe start thinking of getting new dry ice. So it depends on the species, how easy it is, how easy it breaks, and how kind of volatile it tastes. So you never know. But I'm not that scared of contaminants coming out. I just not putting them back. That's the rule, right? If they are out, they are out. I'm suspecting that these 3 tubes are enough for 6 samples or 7 samples.
Yeah. And we need 3, in principle.
Yeah.
Which protocol?
Each 2 of you are doing 2 pairings. So we have a kind of a parallel.
Okay.
So each one of you are crushing 1 sample basically. Yeah.
Okay.
Yeah. So we will have 6 altogether, and then Irene will do 2 low input samples. So we have 8 in total. So for the enzymatic part, you will be making master mixes for 8 samples, and then you will take turn distributing that to all the 8 samples we have. So normally when we start weighing the tissue, I would just tar these weighing ships or boats, whatever you call them. Like that. And then I just place them on the dry ice to keep them cool. I take the sample, and this is sample number 5764, and it's loose in the tube, so it's simple for us. I pour it in the ship and quickly transfer it to the weight, and it's 217 milligrams, which is a bit much. I transfer it back to the dry ice, it's still frozen. So this one needs to be divided into smaller pieces. Basically we need to cut it in 2 to be around 100 milligram. If it's 100 milligram or 120, it's not that important really.
The weight depends on the tissue and the animal you are...
It's not super critical. We have been using 50 milligram low input on mammals even, and it works.
50?
Yeah, 50 milligram.
No, okay, yes. But I'm wondering, yeah.
Because you can make HiC larvae from less than 1 million cells, right?
Yeah.
Without problems.
Yeah. With mammals, yes. With other species, I think maybe I don't know how to do it, no? With corals and stuff like that, that you have few amounts of cells in the tissue, because you have a lot of calcium.
When you weight the corals, you weight the exoskeleton plus the polyps, and the most important is only the polyps. So we generally weight a bigger volume, a bigger weight, and then we put...
So you put 200 or something like that, no?
Yes, but we apply the low input protocol.
Yeah, okay.
But generally, for other samples than mammals, we prefer to use lower input because you have a lot of secondary metabolites, and that inhibits the reaction after. So we prefer to use for exotic samples the low input protocol.
There are scissors
Have you tried any nuclei isolation protocol?
somewhere. I put scissors somewhere around there. On the table?
On the table.
Yeah.
And also something else you could think of is that all your tools, it's a good thing that they are kind of cold, especially if you start working with tissues that are kind of mushy, because which quickly thaw. And then you also need something cold to treat them. Otherwise, it's very easy that you get ice on it and they stick to your tools. You could just put it in dry ice. It's kind of clean, but you know, if this is dry ice that has been reused, it's not a good practice. So put them in some tube or something. All right, so this is 200. So now I would check how easy is it to actually cut this. And on a perfect surface like this, that's very easy. So I'm just right. Okay, since this is, we have more than enough tissue, we can go on with the next one.
What happened?
Oh, no, I mean, this is a test. This didn't happen.
But that's okay because dry ice is clean.
Yeah. This is 136.
And which tube is it? The label of
64.
64?
136.
No, it was
Well, this one is not necessary to divide, no? Or yes. Will you?
the second one?
Would you divide this one, or did you?
We could try to break some of it just to have it closer to our target of
I think it's okay.
of 100, but as you saw, it kind of quickly disappears.
Yeah.
So one solution is to do this, and it doesn't work. So I give it a smack.
Okay.
Like that. And suddenly it's a bit more controlled. It could be really hard, but it isn't really. So this is kind of easy tissue. But now we need to transfer it back to the weighing ship. And I do that by taking the cold spatula or some tweezers if you have them. Do you have them? Where did I put it?
You had them there, but I think they fell, no? Or what?
Maybe they
They're
fell
in
down.
between the two boxes. Yeah.
You can
Oh,
get an clean
yeah.
one if you want.
I think herring is.
That's the herring.
Yeah, we'll have a good genome. It will be easy to map.
Yeah. That's also something to think about, right? When you do this, you normally have a good quality reference of long reads. So any contaminants wouldn't map very well.
Yeah.
So this is 94 milligrams. So I think we stop there. So this we can put in the first tube and have it for later, right? Oops.
Oh.
Yeah, I should have done that. Normally I would do like that. So this is now maybe not, it's 76 because I lost some. Okay, and you see that I throw this away somewhere because it starts to melt right away. Okay, so I put the lid on. So now that was number 1. And it's still cold and frozen. We have leftovers here inside the mortar, but that's not a problem for us because we are repeating the whole thing with the same individual. So it doesn't really matter. But if you like to do this now, just take one sample each, and just record from which one you're taking. I have kind of used one already. So, but we have more if we run out. Okay, so now we have measured out the tissue amount here. This is 120 milligram. So it's already kind of polarized to a certain degree, but we need to polarize it into a fine powder. And there isn't any tricks by doing that. It's just brutal force and time that decides how fine this powder is going to be. So to avoid pieces splashing out, you can cover it with your hand like that if you need to hammer it. Or you can just press it gently and use some force, and it normally works. And you see it works. So I just stab like that to get it into some sort of finer powder, and then you just start grinding it. All right, we have the tissue in our mortar it's already a bit crushed, but we are on dry ice, so we are fine, no melting has happened. But to keep it cold, we always add liquid nitrogen, right? Now, when you add that, it might splash a bit. Like that. But you see, it's not fizzing for a very, very long time here, so it means that the whole thing is quite cold. And now you will have this into a kind of a liquid for a while, and then it gets kind of soft. And you start grinding when the liquid nitrogen has evaporated, like that. I grind for a while and making sure to get those larger pieces also crushed. If you were working on normal ice, you have to add liquid nitrogen often. That's the benefit of working on dry ice bed. This is kind of cold now, right? But once in a while, I would add some. Okay. So what we want is a really fine powder, right? For these samples, this only takes a couple of minutes to achieve. So this is what you want, right? A really fine powder. Always do a bit of extra than too little, because this is a very time-consuming step, right, in the whole protocol. So spend another 3 to 5 minutes to really make sure that this is a really fine powder, flour-like. Now I would add liquid nitrogen to kind of collect it on the bottom, and then we will transfer it to our tube and keep it on dry ice until we are ready to do the cross-linking.
Okay.
The alternative now is to get it into the tube and weigh it once more to really be sure that this is the tissue amount we have. But I would rather accept that if I don't get all of the powdered tissue from the mortar, it's kind of a 10% loss. It's fine. So I'm trying to kind of collect everything at the bottom now that I'm happy with the crushing, like that. I have a spatula that's already cold here, and you can start scraping like that to collect it. So I leave it up to you to decide how eager are you to get this clean. But I mean, if you're working on dry ice bed, you can spend 2 hours doing this. If you work on regular ice, you have to just scoop it up into the tube, then put the tube on dry ice. So let's continue. So this is the tricky part when it comes to freezing your finger. Because you want to take this, which now will contain some dry ice on the bottom, and you want to transfer it into there. It means that you will hold the mortar and at the same time try to scoop it in.
Can we use those gloves over there?
So, exactly. Please use some cold resistant gloves. So during the grinding, I prefer using kind of regular. I have put on 2 pairs to protect myself a bit, and that's normally fine. But when you want to hold this, you need either a pad or proper gloves. Of course, there's always a risk now that some of this you will contaminate your cold-resistant glove, but that's the way it is. But you're not scooping from the glove, and you should have several pairs, and you can kind of wash them, if you like. So I tried to do this. You see that the powder is still cold, right? Here you could also use, what do you call it, funnel?
Yeah, funnel.
Funnel, to make it easier for you to transfer the sample. That should also be cold. You can just put it on the dry ice.
Then you end up using some stuff attached to the funnel.
Potentially.
Yeah, that's the thing with all these cross-linking things where you have a lot of sample transfer from tubes, from mortars, etc. and also a lot of washing steps. You will lose sample at each step. Okay, now I'm happy. It's maybe 10 to 20% loss at the most.